you ever wondered how fruit farmers determine how much water to use, when to use it, and how they predict next year's crop size? Though the way they process, sell, and store fruit has dramatically changed over the years, most permanent agriculture farms still rely on their instincts, in-person observations, and faraway weather stations to determine tree watering, chemical applications, and forecasts for production. These ineffective measures result in wasted resources and inaccurate yield predictions. Cost-effective IoT technologies have the power to change that. I'm Caroline Montanari, a member of the Agrinauts team, a collaboration between RDT West and the local Slalom Seattle office. We created Agrinauts to explore the intersection of agriculture and IoT technology and investigate the gains mass data collection and analysis can provide. We partnered with Allan Brothers, a large, vertically integrated producer of apples, grapes, and cherries located in the Yakima Valley. In the following clips, we'll hear from Allan Brothers leaders about the challenges they face and the opportunities IoT provides with microclimate tracking and resulting predictive analysis.
So when is that vine or tree uptaking water so that we're not applying irrigation water when it's not actually needing it? And within that, when is the optimum time to put nutrients into that water that can be uptake so that it's going to get maximum usage as well? It's really our focus in trying to take those variables that right now we're very reactionary to. We want to move that back to understand, based on what we know, based on history and taking machine language and some artificial intelligence within that. When these things are happening, this is what that outcome may be, so that we can react to it now to prevent either a negative consequence or ultimately be able to provide a more consistent supply.
So a lot of what we're trying to do is depict the story of what the apples are experiencing through their lifespan. So when we're really missing the data for what stresses they're experiencing, we're only getting part of the story. We're getting a story right now of what stresses someplace a couple miles away might have experienced, not what's actually happening. And so being able to identify that would help us determine, do we need to apply more water or less water? Do we need to provide more shade, less shade? Should we be applying different nutrients perhaps to change the way a fruit responds during maybe heat periods, things like that? I think one of the biggest factors is knowing how to apply our irrigation way more strategically than we are now. Right now we're kind of blanket irrigating different blocks, so we turn an irrigation set on and it's just based on a certain amount of time. But if we know how much water is evaporating from the soil and then is evaporating or being used by the tree itself, then we know exactly what we should be replenishing it with instead of just turning it on broadcast across the entire orchard. Also being able to know, like, if we don't have as much heat stress, maybe we don't need to use evaporative cooling a lot. And that too is another huge water use that we use to grow apples.
Right now the big problems we have is around cost. Commercial technology used in agriculture to measure weather is very cost prohibitive for a lot of growers. So to be able to stretch that out, people measure weather further and further apart. If we are able to lower the cost of measuring weather, we're able to get it closer together and focusing more on climate temperature and changes in a smaller area, we're able to better target in what type of fruit we need to grow, how we grow it, what type of yield we get from the fruit. But the further we stretch it out, the less inside knowledge we have, the more guesses we have to make along the way. But it's usually cost that keeps us from getting it closer together. The second main thing is accessibility of services. A lot of commercial entities that focus around agriculture tend to sell their service and data in silos of very specific outcomes. Having access to that data, allowing us to model it ourselves, also means we get better insights and knowledge, so we're able to put that data to work.
To create a solution for Allan Brothers and farms like it, we utilized a wide array of technologies and tools. For data collection in the orchard, we installed several low-cost weather stations throughout the fields to collect critical measures like soil moisture, temperature, humidity, and UV. Those stations send readings of the current conditions every 15 minutes to Weather Underground via RF, which is vital due to the fact many orchards are out of Wi-Fi range. The data is then integrated via Dell Boomi with macroclimate data sourced from a nearby WSU weather station. Using the integrated data, we are able to calculate important measures like evapotranspiration rate, which determines how quickly moisture is evaporating from the soil and directly informs when and how much to water for optimal tree health. We are also building out predictive models using Azure Machine Learning Services. All of this information is fed into a Power BI dashboard to easily view trends, current conditions, and model estimations. There is also an alert system in place so that if temperatures are reaching a dangerous level, Allan Brothers is notified and they can then investigate the issue further using a Power BI dashboard. With the very specific microclimate trends and forecasts reported out in a readable format, now Allan Brothers can reduce water consumption, nutrient usage, labor, and fuel costs while improving yields. As we demonstrate this impact over the coming weeks and months, we hope to extend this solution to other permanent crop farmers in the area and beyond. With the help of our product, permanent farmer resource usage and crop predictions will improve, resulting in a more sustainable farming industry that is mindful of their use of their finite resources. Thanks for watching. Bye.